Hello, scientific people of Standard Ninth. Welcome to DAV Mall Public School. Yes, today we will start the fresh chapter of science, that is motion. So, as you can see in this picture, a car is moving from one point to another point. So, we will say this car is in motion. So, we will understand this phenomena more precisely in the coming slides. So, what exactly do you mean by motion? If an object which is changing its position with respect to time, we will say that object is in motion. As you can see, there are two pictures. This person is changing his position with respect to time, so we will say this person is in motion. So, the branch of physics which deals with the study of motion of an object is known as mechanics. Whoever is studying motion, we will say he is studying mechanics. Now, we can understand this mechanics in terms of two things. First, when the object is at rest, and the other when the object is in motion. As you can see in this picture, this tree is not changing its position with respect to time, so we will say this tree is in motion. With a similar thing, this electric pole is not changing its position with respect to time, we will say this electric pole is at rest. Whereas this bird is migrating from one point to another point, we will say this bird is in motion. With a similar thing, this fly is changing its position with respect to time, we will say this fly is in motion. So these are certain examples from which you can understand rest and motion. Now, mechanics consists of three branches, that is statics, kinematics and dynamics. So what exactly do you mean by statics? So the branch of mechanics, since we are studying motion, so the branch of mechanics which deals with the study of object at rest is termed as statics. For an instant, if an object which is at rest but still something is happening inside that object. So if an individual which is studying if an object which is at rest, so which means he is studying statics. In the similar manner, kinematics, the branch of mechanics which describes motion without going into cause of motion. So which simply means, if I give an example, for an instant, if a body is falling from certain height, so we will simply think about gravity. The body has fallen from a certain height due to gravity. We will not talk about what is the temperature behind it, what are the external condition, why is the object falling from certain height. We will not study about this. So if we consider only the motion which is happening, that we will say that it is kinematics. Another example of kinematics would be, for an instant, if we are studying certain objects, like we are studying certain, if a car is moving from one point to another point, we will simply focus on the position of an object. We will not think about what sort of material the car is made up of. We will not study about that. So we will simply focus on car has moved from one point to another point. So we will simply say we are saying that car is possessing a kinematic motion. In the similar manner, dynamics. In dynamics, we have to consider the different causes of motion. So if we think again, if I take an example of that car, now if I talk about the external condition, what sort of material car is made up of, along with the what is the motion of the car, what sort of engines are is there in car. So I am considering overall motion of car, which includes the different causes of motion. So which means I am studying dynamics. Now there are different types of motion, as you can see. First one, rectilinear motion, circular motion, rotational motion and periodic motion. So rectilinear motion means a simple straight motion, whereas circular motion means an object which is revolving or moving in a circular path. Rotational motion means an object which is revolving around its axis, that is rotational motion, whereas periodic motion means to and fro of an object, a motion of a to and fro, that is periodic motion. This example is simple pendulum. Rotational motion example is this football which is rotating about its own axis. You can even relate the motion of a earth is again an example of rotational motion. The circular motion, this is the circular motion. An athlete is running in a straight path, that is rectilinear motion. So these are certain types of motion. Again, there are many different types of motion. Now, what do you mean by point object? Now, point object, as you can see, this is a point object and this is an extended object. So point object has no physical extent. What do you mean by physical extent? It doesn't have any length, width or height. If an object which doesn't have any length, width or height, we will say it is a point object. And another way of seeing point object is that if the position of an object changes by a distance much greater than its own size in a reasonable duration of time, we will say it is a point object. The example would be, for an instant, an astronomer is observing a motion of a body which is there on the surface of the earth. For the astronomer, that motion would be considered as a point object. Since the distance between the astronomer and that object is very far, the object is covering a distance much greater than its own size. For the astronomer, that object would be considered as a point object. Now, motion in one dimension. There are different dimensions. This dimension concept you will study in 11th standard, but little bit about motion in one dimension. Now, one dimension means if an object which is moving either only in one axis, we will say that motion is in one dimensional motion. For an instant, if an object is moving in right direction or if an object is moving in left direction, so it is using only one axis, so which means it is a 1D motion. For an instant, if an object which is falling from the surface of the earth, or if a person is throwing an object above the surface of the earth, so this type of motion would be there. Only one axis would be involved again, so we will say it is a 1D motion. Certain examples I wrote over here. For an instant, these are certain examples. Yes, these are certain examples, like say a motion of a bus on a straight road. So bus is moving and bus is utilizing only one axis. That is, bus is in 1D motion. If an object which is falling, for an instant, if an apple which is falling on the surface of the earth, it is utilizing only one axis, that is y-axis. So we will say it is a 1D motion. In the similar manner, we also have 2D motion and 3D motion, and we simply have 3 motion at time. We don't have 4th dimension, that is time. There are 3 dimension, 1 dimension, 2 dimension, 3 dimension and 4 dimension. 4th dimension is time. In 2nd dimension, we use 2 axes, x-axis and y-axis. For an instant, if a lizard is there on the wall, and its motion would be only in 2 axes. Either the lizard will move only in x-axis or in y-axis. So that motion would be 2D motion. For an instant, if I keep a circular object on a 2D motion, so which means it will utilize 3 axes, x, y and z. So that football or a circular object would be a 3D motion. If a person who will say I will neither move in 1D motion, 2D motion or 3D motion, I will move in another, I will say a motion which is a mixture of 1 or 2 motion, that would be a mixed motion. If a person which is utilizing in one motion, 1D motion or 2D motion, that would be a mixture of 1D and 2D motion. There is no 4th dimension as such. As 4th dimension, that is time. You will understand this concept in higher classes about 1D motion, 2D motion and 3D motion. Now, uniform and non-uniform motion. Now, uniform motion means if a particle covers equal distance in equal interval of time, we say it is a uniform motion. For an instant, this is a picture. For an instant, if an object is moving from this point A to this point B, the distance from this point A to this point B is supposed say 10 kilometer. An object is covering that distance in 5 minutes. With a similar thing, this B and C distance, the distance is again 10 kilometer. The time required from B to C is 5 minutes. You might have observed that time and distance are same. So if object is covering equal distance and equal interval of time, so we will say it is a uniform motion. The example would be, this is a motion of a clock. In this clock, the second hand clock is moving in a certain duration of time. So that we will say that is a motion of a uniform motion. Whereas another example of this uniform motion is Earth revolving around the sun. Earth revolves around the sun It takes 365 days, 5 hours, 39 minutes, and 16 seconds to revolve the one complete orbit of a Earth or orbit of the Sun. So this is again a uniform motion where time period is fixed. So we will say Earth revolution of the Earth around the Sun is an example of uniform motion. Whereas exactly vice versa of uniform motion is non-uniform motion. If an object covers unequal distance in equal interval of time, we will say it is a non-uniform motion. The motion of a vehicle on a crowded street is an example of non-uniform motion. Now, scalar and a vector quantity. Scalar quantity are those quantities which have only a magnitude. Magnitude simply means a number, whereas vector quantities are those quantities which have magnitude as well as direction. So in simplest way to understand the scalar and vector, the scalar quantity will not have any role of direction. For an instant, if I take an example of mass, mass means the amount of matter that is present in a substance. If I change the direction, that quantity will always remain fixed. So which means mass is a scalar quantity and it requires only a certain amount of magnitude. Whereas vector quantities are those which requires magnitude as well as direction. So that are vector quantities. For an instant, force. If I give certain amount of force from one direction, the magnitude and direction, if I change the direction of that force, the resultant net force would be different. So we will say force is a vector quantity. Likewise, we have different parameters or different physical quantities like length, area, volume, speed, mass, density, temperature, pressure, work, power, energy, entropy. These are all scalar quantities which does not depend upon direction. It only depends upon magnitude. Whereas vector quantities are those like displacement, direction, velocity, acceleration, momentum, electric field, magnetic field. These are vector quantities. So vector quantities are represented with an arrow. Now in 11th standard you have to understand something about vector quantities, wherein you will study about unit vectors and its related phenomena. So vector quantities you will be dealing very frequently in coming classes. So I hope you have understood the concept. Thank you and have a nice day.